If you've been listening to us for a while, we often talk about technology's relentless march forward. I mean, just think about it. The iPod back in 2001, the World Wide Web in the 90s, mobile phones kicking off in the 70s, even color TV way back, the 60s? Each one was this huge cutting-edge thing, right, sweeping through society. But then it gets refined, improved upon, maybe even replaced by the next big wave. It's like this constant flow of innovation building on itself.
Yeah, it's a familiar pattern.
But here's the curveball we want to explore today. What if that same basic logic, that evolutionary process, applies to something we usually think of as totally different? What if it applies to art?
It sounds a bit surprising at first, doesn't it? But that's exactly what we're diving into. And what's really fascinating is that the underlying logic of how culture evolves is, well, basically identical to biological evolution. Obviously, the mechanisms are different, but the pattern, well, new ideas or behaviors, maybe new products, they emerge, right? Through all sorts of creative ways. Then they differ in how much people like them or how useful they are. And the ones that catch on, the most attractive or effective ones, they get adopted. They, supersede the older, obsolete stuff.
Okay, like survival of the fittest, but for ideas or styles.
Exactly. And this applies to everything, really, from like simple pins ages ago to complex things like gene editing today. And what we want to unpack is how this framework really illuminates the evolutionary journey of the arts, which often gets overlooked.
Okay, so let's dig in. Our mission here, for you listening, is to explore how culture, especially art, evolves over time. We want to show how the very things that make us human, our incredible brains, our knack for imitation, have shaped everything from the movies you stream to the dances you might see or even do.
It's quite a thought, isn't it? The same evolutionary pressures that helped our ancestors survive are kind of subtly shaping your Netflix choices today.
Let's kick off with something really basic but powerful. Imitation. We see its role in technology all the time, right? Think about Alan Turing. His first computer wasn't just about calculation, it was trying to imitate the human mind.
A foundational idea.
Then fast forward, you get Deep Blue beating Garry Kasparov at chess in '96, a machine mind showing its power. And now, we've got supercomputers like Tianhu or even the quantum logic clock, this hyper-accurate clock using just one atom's vibrations.
Incredible precision.
But guess what? Sometimes they're still called quantum Turing machines. It's like a nod back, acknowledging that imitation heritage. It's all about copying, refining, building up.
And what really grabs me here is that this deep reliance on imitation isn't just for tech. It is absolutely fundamental to the film industry. I mean, every single actor, Benedict Cumberbatch playing Alan Turing, Marlon Brando as Vito Corleone, Meryl Streep channeling Margaret Thatcher, they make their living by meticulously imitating characters.
Huh. I never quite thought of it that way.
Think about it. The Oscars, the Golden Globes, fundamentally they're awards for the world's best imitators. Wow.
Okay.
Which immediately brings up a huge question. If imitation is so central, why are humans just so incredibly good at it?
Right. And it's not like being a fantastic actor gave your Stone Age ancestor a survival advantage.
Exactly. No amateur dramatics in the Pleistocene savannah.
So acting skill is more like what you call an exaptation.
Precisely. A trait that natural selection favored for one reason, maybe a really crucial survival reason, gets repurposed later for something totally different.
So acting is like a fancy byproduct of selection for really good copying skills that were genuinely life or death for our ancestors.
That's a great way to frame it. For our distant ancestors, being a good copier meant huge fitness benefits. But they weren't copying characters, they were learning vital life skills.
Like making tools.
Absolutely. Making digging tools, spears, harpoons, building and maintaining fire that's complex, butchering carcasses efficiently, hunting strategies, defending the group against predators.
And reading people too, I guess. Social cues.
Definitely. Interpreting intentions, coordinating actions. Hundreds of skills like these shaped our lineage's imitative abilities over, well, potentially millions of years. Being able to learn these effectively through observation and imitation was critical for survival.
So this pressure basically sculpted our brains.
It seems so. It led to this disproportionate growth in brain areas vital for processing what we see and controlling complex movements. Regions like the temporal and parietal lobes, that's where scientists first found those mirror neurons, which are thought to be heavily involved in imitation.
Which brings us to that tricky thing psychologists talk about, the correspondence problem.
Ah.
How do we see someone else doing something, like, say, using chopsticks or riding a bike, and translate that visual input into the completely different feeling of doing it ourselves, moving our own muscle.
It's a real puzzle for researchers, but it just underscores how amazing this adaptation for imitation truly is. It's not simple mimicry. It's a sophisticated cognitive feat.
Okay, I'm following.
And connecting this back, the same brain power that lets us learn to make a spear also allows Jimmy Stewart to make us feel things every Christmas. In It's a Wonderful Life, the whole movie industry generating, what, $40 billion globally back in 2015, hinges on us, the audience, being able to vicariously feel emotions, to imagine ourselves in the story.
That empathy, that emotional contagion.
Exactly. It probably evolved in our ancestral social groups. Imagine how useful it is to feel fear when someone else shows fear. It helps you learn about dangers, right? Predators, pitfalls, whatever.
Without that, movies would be cold.
We'd watch them like sociopaths, completely unmoved by the drama, the horror, the romance, no tears at the end of a rom-com.
Okay, so think our ancestors' survival needs for movie night emotions.
Pretty much.
Now, shifting gears slightly, but still on art.
Oh.
What about sculpture? How on earth did Michelangelo sculpt David? That seems like another level of that correspondence problem, doesn't it? Translating a visual idea, or maybe a model, into incredibly precise hand movements with a hammer and chisel.
It's mind-boggling, truly. And it hammers home how unique this capacity is to humans. Only a species with a really large brain like ours could possibly achieve that kind of sculptural precision.
It's about the brain size.
Largely, yes. Our neocortex, that makes up about 80% of our brain volume, and our cerebellum have expanded dramatically during human evolution. This gives us vastly better control over our motor neurons, leading to incredible manual dexterity and fine motor skills.
The kind you need for sculpting or painting.
Exactly. But also for acting, playing complex musical instruments, opera singing, and very relevantly for dance.
Okay, so if these artistic abilities rely on these uniquely developed human traits, does that mean real art is only human? Because the internet loves videos of artistic animals and painting dogs, elephants. You can even buy kits.
Right. Those videos are definitely popular and often quite charming, but animal behavior experts and art scholars, too, tend to view claims of animal art pretty skeptically.
Is that?
Well, take Brent the chimp, who apparently won an art contest using his tongue. Or those famous painting elephants in Thailand doing realistic pictures.
Yeah, I've seen those.
While it shows animals can be trained to do impressive things, and they do have complex abilities, like Koshik the elephant mimicking human speech sounds, or Happy the elephant recognizing herself in a mirror.
Okay.
The reality with the painting elephants, for instance, is often that their trainers are subtly guiding their trunks, maybe by pulling their ears. It's clever training, not necessarily spontaneous artistic expression in the human sense.
So the key difference is representation, like making an image stand for something else.
That's a huge part of it. Representational art seems to be a uniquely human thing, built on those advanced imitative and cognitive abilities we've been talking about.
That makes sense. And our big brains gave us more than just hand control, right? Vocal control, too.
Absolutely. The dexterity for complex speech and for song.
And language feels central here because human art is just soaked in symbolism.
It really is.
I'm thinking of that bit in Victor Hugo's Notre Dame de Paris.
Oh, yeah.
Where the Archdeacon Frollo is raging against the printing press. He fears it'll destroy architecture's power as a kind of book of stone.
Right, because buildings were the texts back then, in a way.
Exactly. To us, it sounds crazy, but in a world before mass literacy, cathedrals, pyramids, they literally encoded authority and belief in their design, filled with symbolism. It was a visual language.
That historical perspective is vital. And human artwork goes way back, maybe 100,000 years. And you can see cultural evolution clearly, variation, selection, inheritance.
Like in painting.
Definitely. Think about the whole tradition aiming for realism or mimesis, trying to copy reality accurately. You get someone like Rene Magritte painting a pipe and writing, "This is not a pipe," underneath.
Oh, yeah. The treachery of images.
He's making that very point, like, it's an image, not the thing itself. It highlights the artist grappling with that correspondence problem. And today you have hyperrealism, where artists create paintings so lifelike they look like photos. They're pushing the absolute limit of translating vision into physical form, just like tech evolves.
Okay, this evolutionary lens is starting to make sense across different art forms. But you mentioned dance earlier.
Yes.
And here's where it gets really interesting, I think. You're saying dance might directly use the same brain circuits that evolved for imitation.
That's the idea. Nowhere else in the arts is the correspondence problem so obviously in play. Dance fundamentally requires integrating different sensory inputs and motor outputs. It seems plausible, even likely, that dancing is only possible because it taps into or exploits that neural circuitry built for imitation.
How so? Specifically in dance.
Well, think about it. Dancers have to match their movements to music, right? That's translating auditory input into motor output.
Auditory to motor, okay.
And if they're dancing with a partner or in a group, they have to coordinate, match, or complement the other person's movement. That's visual input to motor output.
Visual to motor, got it.
Our ability to handle these complex translations, sometimes with incredible grace and speed, seems rooted in that unique neural apparatus we inherited from ancestors who needed to be good copiers.
So the basic ability is there, but you still need practice.
Oh, absolutely. The potential is innate, but competence comes from experience. Even things like being rocked as a baby start building those neural links between sound, movement, rhythm.
And doing things in sync, like tapping your foot.
Even that simple act strengthens those self-other connections. Brain scans actually back this up. Moving your foot in time to music lights up brain areas linked to imitation.
Fascinating. But okay, the inevitable question. Can animals really dance? Not just move, but dance.
Well, it really hinges on your definition of dance. If we ask, can animals move their bodies rhythmically in time with music, then the answer seems to be yes, for some. What's really striking is that nearly all the animals shown to do this, certain birds, elephants, even chimps, are also known to be really good vocal or motor imitators.
There's that imitation link again.
Exactly. It led researchers to propose the vocal learning and rhythmic synchronization hypothesis. Basically, a tight connection between the brain circuits for hearing and processing sound and those for controlling movement.
Any famous examples?
Snowball, the sulfur-crested cockatoo who became a YouTube star.
Oh, yeah, I think I've seen Snowball. Head-banging to Queen.
That's the one. And scientists took Snowball into the lab and proved he could genuinely adjust his movements to match the beat of music, even when they changed the tempo. Even a chimp, known for motor imitation, showed rhythmic entrainment. So while they might not be doing the tango, their ability to sync with the beat points to those underlying imitative circuits.
Okay, so maybe rhythm, but what about this storytelling aspect of dance? The representation.
That's another strong link to imitation. So much dance involves imitating movements or even sounds of people, animals, natural events.
Like ancient dances.
Yeah, think of ancient Egyptian priests doing astronomical dances, mimicking the stars and planets. Or Australian Aboriginal dances, depicting spirits, animals for love potions, hunting scenes.
And Native American dances, too. Buffalo dances, eagle dances.
Exactly, paying tribute, maybe trying to lure game, embodying the spirit of the animal. It's imitation as representation. Even modern groups, like the Rambert Dance Company, create pieces evoking animal behavior. It's an ancient impulse still very much alive.
And how do dancers learn all this, especially complex choreography?
Almost always through imitation, watching an instructor, a choreographer, maybe other dancers.
That's why dance studios have mirrors everywhere.
Precisely. So dancers can constantly compare their own movements to the model, see the differences, and correct them. It speeds up learning massively. Being able to pick up routines quickly is a key skill for professionals. As one dancer put it, quite bluntly, dancers earn their living by imitation.
It really is imitation elevated to a high art and profession.
Absolutely.
But it's not just copying single moves, is it? Choreography involves long sequences.
True. Dance demands sophisticated sequence learning, the ability to learn and reproduce complex sequences of actions. And guess what? That's another skill likely honed in our ancestral past, probably for things like making complex tools or processing food, which often involved specific, ordered steps.
Wow. It all connects back.
It really seems to.
So if we look at dance through this evolutionary lens, it should show those core principles, right? Variation, fitness, inheritance.
Perfectly. Dance is a fantastic case study. Let's break it down. Variation. Oh, absolutely massive. Think of the thousands of distinct European folk dances alone. Sword dances. Highly regional Spanish dances like flamenco. Then compare the whole aesthetic, the lightness, the leaps, the point work of Western ballet versus the more grounded, earthy, sometimes stamping movements in many Eastern traditions. Huge variation.
Okay, variation is clear. What about differential fitness? Dance is becoming popular, replacing others.
Definitely. Few things shook up the dance world like the waltz hitting Paris around the end of the 18th century.
A waltz, really?
Oh, yes. Its swirling motion, the close, dangerously intimate contact. It was intoxicating. It just swept across Europe, pushing out the more formal, stuffy minuets. The waltz was simply fitter for the changing social scene.
Like a dance craze.
Exactly. Polkamania followed later, another craze. And think about American dances. The Charleston, jitterbug, rock and roll, disco, they all crossed the Atlantic, becoming global phenomena, often overwhelming older styles. They had higher fitness in their time.
Inheritance, dances being passed down, evolving over time.
Absolutely central. Circle dances, for example, you can trace lineages back thousands of years, maybe to ancient Egyptian rituals, through medieval religious ring dances.
Yeah.
The English Morris dance likely has Moorish roots from the time of the Crusades, blended with even older fertility rites.
Wow.
Even something like modern rave culture, with its intense repetitive rhythms and almost trance-like state, you can see parallels throughout history, maybe back to the Dionysian dances of ancient Greece. We're constantly inheriting and tweaking old forms.
Can we maybe trace a specific style?
Yeah.
Like ballet?
Sure. Ballet's evolution is fascinating. It starts in 15th century Italian Renaissance courts. Not really performance as we know it, but part of grand social events with professional dance masters arranging things.
Okay.
Then it moves to 16th century France, heavily promoted by Catherine de' Medici and later King Louis XIV, who was a passionate dancer himself. This is where it gets more formalized, codified, integrated into opera ballets.
And then Russia.
Then it's 19th century golden age, largely in Russia. That's where we get the classics like the Nutcracker, Swan Lake. You see huge technical evolution, more demanding point work, the introduction of the tutu, more athletic roles for male dancers. Each stage inherits, but also innovates, increasing its fitness or appeal.
And then modern dance kind of breaks from that tradition.
Right. Contemporary dance emerges often in direct reaction against ballet's perceived rigidity. Pioneers like Isadora Duncan famously rejected the conventions, the shoes, the tutus, the strict technique. She wanted flowing, natural movement inspired by Greek art.
A radical variation.
Absolutely. Her life was tragic, but her influence was revolutionary, opening the door for others. Then you get figures like Ruth St. Denis, drawing inspiration from Asian cultures, and her student, Martha Graham.
Martha Graham is huge in modern dance, right?
Foundational. She didn't just create dances, she codified an entire new language of movement, focusing on the torso, the lower back, the pelvis as the source of power and expression. She created a new lineage, a new form of inheritance for dancers to build on.
What about Latin dances? They seem so full of life and history.
They really are, and they perfectly show that cultural mixing and evolution. Take the tango. Its roots might lie in Cuban slave dances, which then traveled to Argentina, mixed with local influences in the working-class districts of Buenos Aires, and eventually became the sophisticated, passionate ballroom classic.
Wow, quite a journey.
Or the samba in Brazil. Clearly African roots from the slave trade, blended with European influences, eventually becoming the absolute symbol of Brazilian national identity and carnival.
So these dances absorb influences, they change, they adapt.
Constantly. They are living examples of cultural evolution happening right before our eyes, often blending variation, fitness, and inheritance in really dynamic ways.
While we're talking about dance,
Yeah.
why do people enjoy it so much? Is there an evolutionary angle there too?
There probably is.
Yeah.
On a simple level, there's the physical pleasure, right? Exercise releases endorphins.
The runner's high, but for dancing.
Kind of. And the social interaction, especially potentially finding a mate through dance, can release hormones like oxytocin associated with bonding and pleasure.
The courtship aspect.
Definitely. But maybe even more fundamentally, think about coordinated, synchronized movement like in group folk dances, a Sealid, or watching something like river dance. Doing things together in time seems to create a really powerful sense of social bonding and shared enjoyment.
Why would that be?
Well, there seems to be a deep link between imitation and cooperation. Studies show that if someone imitates you, you're more likely to cooperate with them. And if you feel cooperative, you're more likely to imitate others. It's a two-way street. So, if natural selection favored rewards for synchronous behavior because it helped groups cooperate better, maybe for hunting, defense, whatever, then dancing together synchronously would naturally tap into those reward pathways and feel good. It literally helps bring groups together.
That makes a lot of sense. And you mentioned earlier that dance doesn't evolve alone. It's connected to other parts of culture.
Oh, absolutely. It's constantly interacting, cross-fertilizing. Think about music, they've always gone hand in hand.
Obviously.
You can't have traditional African dance without drums or flamenco without the guitar and singing. The waltz craze fueled composers like Strauss. Rock and roll, disco, salsa. The music and the dance are inseparable. They share the same name.
Right, and fashion?
Hugely intertwined. Costumes are vital. Marie Taglioni bringing in point work and the romantic tutu fundamentally changed ballet's look and feel. Isadora Duncan, Margot Fonteyn, they became style icons way beyond the dance world.
Designers creating for dance.
Yes. Coco Chanel, Yves Saint Laurent, Valentino, Vivienne Westwood. Major designers saw dance as a dynamic platform. Even disputes over costume, like Virginia Zucchi wanting a shorter tutu or Nijinsky refusing to wear traditional cover-ups over his tights, show how much fashion mattered. These were cultural moments.
And connections to visual art. Theater.
Definitely. Edgar Degas is famous for his paintings of dancers. Picasso designed sets and costumes for Diaghilev's ballet Russes. Martha Graham collaborated closely with the sculptor Isamu Noguchi on her stage designs.
Cinema, too, you mentioned popularizing dances.
Massively. From the elegance of Fred Astaire and Ginger Rogers in films like Top Hat or Singin' in the Rain, making tap and ballroom look effortless,
Classic Hollywood.
to the explosive energy of West Side Story, the disco fever sparked by Saturday Night Fever, or the rock and roll nostalgia of Grease, movies took dance styles global.
Technology must have played a role, too.
Huge role. Music recording, the gramophone, then radio, records, tapes, CDs, iPods allowed music to spread, and the dances followed. Cinema and then TV beamed images of dance everywhere. Even printing helped, with lithography spreading sheet music and sometimes even dance steps.
And it supports whole industries now.
A vast ecosystem. Professional dance companies, dance schools, choreographers, costume makers, nightclubs, even dance therapy. It's a major cultural and economic force.
Okay, so bringing this all together, what's the big takeaway for you, listening? If we can understand something as diverse and complex as the history of dance, using these basic evolutionary ideas, variation, differential fitness, inheritance, then that same logic, that same framework can probably be applied to almost any area of culture.
That's the power of it.
Think about food.
It's a really profound insight, I think, because evolutionary biology doesn't just help explain how culture changes, it also helps explain how the underlying human abilities, the psychological, neurological, physiological traits needed for culture actually came about in the first place. It starts to answer that question that puzzled even Darwin. How on earth do we account for the sheer majesty and complexity of human culture? This framework suggests it's not some magical exception, but a natural outcome of the same evolutionary forces that shaped life itself.
And importantly, understanding the origins scientifically doesn't have to diminish the wonder, does it?
Not at all.
The genius of an Alan Turing, a Marie Curie, and Isadora Duncan, the magic of Mozart or Shakespeare. It doesn't just vanish because we can trace its roots. If anything, the awe might deepen. Maybe a little bit of the mystery fades, but the achievement remains staggering.
Well said.
So here's something to think about. How does looking through this evolutionary lens change how you see the art, the technology, even the everyday traditions around you? Now that you're sort of primed to look for it, what unexpected example of imitation